Somewhere out there, hiding in the oldest light we've ever caught, there's a dot, small, blood red, and it shouldn't exist. You've probably scrolled past a JWST image before. Swirls of gas, glowing nebulae, galaxies stacked like jewels in the dark. Beautiful, sure, but forgettable. This is different. When astronomers pointed the James Webb Space Telescope into the deepest, oldest corner of the universe, they expected chaos. Young galaxies, messy and disorganized, still figuring out how to exist. That's what the models predicted. Instead, they found dots, hundreds of them, compact, impossibly bright, and red in a way nothing that old should be. At first, nobody could explain it. Some called it a crisis for cosmology itself. Here's the part that gets me. These things showed up everywhere in the early universe, and then vanished, like they were never meant to survive. So what were they? And why does something so small keep making some of the smartest people on Earth argue? Stay with me, because the answer changes what we thought we knew about how everything began. Let's go back to the beginning. Not the beginning of the universe. The beginning of the discovery. Summer of 2022. The James Webb Space Telescope has just opened its eye for the first time, and it's staring further back in time than any instrument humans have ever built. Not further away in space, further back in time. Because that's the trick of looking into deep space. The light hitting Webb's mirrors left its source so long ago that by the time it arrives, the thing that made it might not even exist anymore. You're not looking at the universe as it is. You're looking at a ghost of what it once was. And almost immediately, something strange starts showing up in the images. Tiny points of light, not the sprawling, spiral galaxies you'd expect. Just dots, small, dense, glowing with an odd, deep red color. At first, the astronomers barely noticed them. They're small, unremarkable next to the sweeping nebulae and glittering galaxy clusters everyone's busy admiring. But then someone starts counting, and the count doesn't make sense. These dots aren't rare, they're everywhere, scattered across nearly every deep field image Webb captures, all clustered in a specific window of cosmic time, somewhere between 600 million and 1.6 billion years after the Big Bang. In cosmic terms, that's still early. That's the universe in its infancy, barely done cooling from its own birth. And in that window alone, these little red dots are absurdly common. Common enough that if you tried to explain them using the standard model of how galaxies form, the model that's held up for decades, the numbers simply break. There are too many of them. They're too bright for how small they are. And the color is wrong. Deep red isn't supposed to belong to something that young. Red in astronomy usually means one of two things. Something is moving away from us very fast, or something is buried in dust. Neither explanation sits comfortably with what they're seeing. So the scientific community does what it always does when the universe hands it something it can't explain. It argues. Some papers start throwing around dramatic language. Words like broken, like impossible. A few headlines even claim JWST might be unraveling our entire understanding of cosmology. That maybe galaxies form faster or differently or earlier than anyone thought possible. I want to pause here because this is where most videos lose the thread. They tell you scientists panicked. Cosmology broke, cut to commercial. That's not honesty, that's spectacle. The truth is messier and more interesting. What actually happened wasn't panic. It was curiosity turning into obsession. Teams of astronomers started pulling these little red dots apart, piece by piece, trying to figure out what kind of object could produce this exact signature. And the signature itself is strange. When you break the light from these dots into a spectrum, essentially splitting it the way a prism splits sunlight into a rainbow, you don't get a smooth curve. You get a shape, a very specific shape. bright in the blue end, bright again in the red end, but with a dip in between, like a valley carved into the middle of the light. Astronomers started calling it the V-shape. And it shows up again and again and again across dozens of these objects. On top of that, some of them show something called broad emission lines, wide, smeared-out signatures in their spectra that usually mean something is moving incredibly fast. Gas swirling at thousands of kilometers per second. That kind of speed doesn't happen randomly. It happens near something with enormous gravity. So now you have a small, unbelievably common, deep red object radiating light with a strange V-shaped signature and hints of matter spinning violently close to something massive. Whatever these things were, they weren't behaving like normal young galaxies, and they weren't behaving like normal stars either. Something else. Something that, for a while, nobody had a name for. And here's the detail that stayed with me the most. As astronomers kept scanning later and later points in cosmic history, closer to our own time, the little red dots started disappearing, not fading, vanishing. By the time the universe reaches around 2 billion years old, they're almost entirely gone from the data. Something that was everywhere simply stopped existing. That's not a footnote. That's the whole mystery, sitting right there in front of you. Something is born in staggering numbers in the universe's early chaos, and then it dies out, or transforms, or hides, all before the universe even reaches 10% of its current age. So the question stopped being, what are these dots? It became something bigger. What kind of object is born everywhere, all at once, and then disappears completely? That's what we're going to sit with for a while. So let's follow the strongest lead first, the one that right now has the most evidence behind it. Black holes. Not the kind you're picturing, maybe. Not a slow, quiet giant sitting at the center of a mature galaxy, patiently pulling in the occasional star. Something younger, hungrier, almost feral. Here's the idea. In the very first few 100 million years after the Big Bang, the universe was a mess of raw material. Gas, dust, the seeds of the first stars. And in some pockets of that mess, black holes started forming shockingly fast. Not by growing slowly over billions of years the way we once assumed. By gorging. Picture a black hole feeding so aggressively that it's pulling in gas faster than physics technically allows. There's a theoretical speed limit for how fast a black hole can feed. It's called the Eddington limit, named after the astronomer who worked out the balance between gravity pulling matter in and radiation pressure pushing it back out. Cross that limit for too long, and the outward pressure should choke the black hole's own meal. But some newer models suggest early black holes might have broken that rule anyway, feeding in short, violent bursts, wrapped inside dense clusters of gas and young stars that helped contain the mess long enough to keep going. A team led by researcher Hui Li explored exactly this scenario earlier this year, showing super Eddington feeding bursts inside compact nuclear star clusters could reproduce that strange V-shaped light signature almost perfectly. Now here's where it gets beautifully specific. A black hole feeding this violently doesn't just sit there quietly. It gets messy. It throws off enormous amounts of energy. And it gets wrapped, cocooned, really, in a shroud of gas and dust pulled in from its surroundings but not yet swallowed. That cocoon does something important. It absorbs the black hole's high-energy light and re-emits it at longer, redder wavelengths. Think of it the way a street lamp looks orange and soft through fog, instead of harsh and white. The fog isn't the light source. It's changing how the light reaches you. That's essentially what's happening here, except the fog is made of superheated gas, and it's swallowing a newborn black hole whole. That would explain the color. It would explain the strange spectral shape, and it would explain why we don't see these objects clearly at other wavelengths. X-ray, radio, the ones you'd expect from a fully exposed, actively feeding black hole. The cocoon is hiding it. For a while, this theory ran into a serious problem, though. When astronomers first estimated the mass of these black holes using the width of those broad emission lines, the numbers came back absurd. Some little red dots seemed to hold black holes nearly as massive as their entire host galaxy. That's backwards. In every galaxy we understand well, the black hole is a tiny fraction of the total mass. This looked less like an explanation and more like a brand new crisis. This is the part most videos skip because it complicates the clean narrative. But it's exactly why I trust where the science landed. Scientists didn't just accept the alarming number. They went back and questioned the method. And in January of this year, a study published in Nature found something crucial. The dense gas cocoon around these black holes, the very thing giving them their red color, was also distorting the measurements. It was artificially widening those emission lines, making the black holes look roughly 100 times more massive than they actually are. Once that correction was applied, the numbers stopped looking impossible. The black holes shrank back down to a size that actually makes sense next to their galaxies. That's not a small detail. That's the difference between the universe broke a fundamental rule and we were reading the instrument wrong. Sometimes the most exciting headline isn't the true one. Then this past July, a study in the Astrophysical Journal led by Rinaldi and colleagues pulled together Webb's imaging and spectroscopy with archival Hubble and Chandra X-ray data and made the strongest case yet. These little red dots, they argued, are supermassive black holes caught in an early, furious growth phase. Their host galaxies simply too faint and too far away to detect. Not a galaxy-less object. Only the brightest part of something ordinary, from so far away that everything else fades into the dark around it. Distance distorts what we see. It always has. If this explanation holds, it means something quietly profound. It means the earliest supermassive black holes in the universe didn't creep into existence over billions of patient years. They erupted. Fast, violent, almost reckless growth, right at the dawn of everything. But here's what I have to be honest with you about. This isn't the only explanation left standing, not even close. Just 1 week after that black hole paper made headlines, a different team came out with something that pulled the rug out from under the tidy version of the story. 2 studies, led by researchers at the Harvard-Smithsonian Center for Astrophysics, published in the first week of August, offered a rival explanation. Not a small tweak to the black hole idea, a genuinely different object. They call it a black hole star. I know how that sounds, like a contradiction. A star that's also a black hole. But stay with me, because the physics behind it is one of the strangest, most beautiful things I've come across while researching this video. Picture a star, but not one like our sun. Something almost unimaginably large. Roughly 100,000 times the mass of the sun. A star that big shouldn't be stable. It shouldn't even be able to hold itself together for long. Under that much of its own gravity, the core collapses almost immediately, forming a black hole, while the outer layers of the star are still very much intact, still glowing, still very much there. So now you have something genuinely strange sitting in the early universe. A black hole, newborn, sitting at the heart of a dying star that hasn't finished dying yet. The outer layers haven't been blown away. They're still wrapped around the black hole like a shell, like a cocoon the star built for itself without meaning to. And that shell does something remarkable. As the black hole inside feeds on the star's own material, it releases enormous amounts of energy. That energy pushes outward against the star's remaining layers. And because the whole system is teetering on a knife's edge, gravity pulling in, radiation pushing out. The star starts to pulsate, expanding, contracting, breathing almost in these violent rhythmic cycles, shedding gas shells with each pulse like something trying to catch its breath before it finally goes still. Here's what makes this theory compelling, and why I'm not just tossing it in for balance. According to the researchers behind it, this single model, a pulsating, gas-shedding, black hole-hearted star, can account for all three strange features at once. The V-shaped spectrum, the oddly compact size, and a detail I didn't mention before because it deserves its own moment, an unusual abundance of nitrogen in the light coming from some of these objects. That nitrogen signature has puzzled astronomers for a while. It's not something you'd expect from a normal galaxy at this stage of the universe's life, but it's exactly the kind of thing you'd expect from a colossal, unstable star violently shedding its outer layers, exposing material from deep inside itself that's normally hidden. Think about what that actually means for a second. If this theory holds, then what Webb caught a glimpse of wasn't simply a black hole quietly growing inside a normal galaxy. It caught something rarer, a transition, a star so massive it couldn't survive its own existence, caught in the exact narrow window between being a star and becoming the seed of the black hole that would eventually grow into something like the monster sitting at the center of galaxies today, including our own. It's a birth and a death happening at once in the same object, witnessed by an instrument sitting 1,000,000 miles from Earth. I find that unbearably beautiful, honestly. Not because it's confirmed, it isn't, and there's a real ongoing disagreement among astronomers about which explanation fits the data better. But because of what it suggests, that some of the very first black holes in the history of the universe might not have formed quietly, in the dark, unnoticed. They might have formed inside something still burning, something still in every sense alive. So where does that leave us? Two explanations, both backed by real data, both published within weeks of each other in 2026, both claiming to solve the same mystery. One says these are dusty, furiously feeding black holes, hidden inside galaxies too faint to see. The other says these are dying, pulsating, supermassive stars, caught in the exact moment they collapse into the black holes that will eventually anchor entire galaxies. And the honest answer right now is that we don't fully know which one is right. Maybe both are. Maybe some little red dots are one, and some are the other. The universe has never been obligated to give us a single, clean answer just because we'd prefer one. What I can tell you is this. However this eventually gets resolved, something profound already happened the moment we found these dots at all. We caught the universe mid-transformation, not finished, not settled, still becoming what it would eventually turn into. And there's something about that, about catching a moment of becoming instead of a moment already complete, that feels less like astronomy and more like being let in on a secret nobody was supposed to see yet. Here's something I keep circling back to while putting this video together. Whichever explanation eventually wins, the black holes or the black hole stars, the deeper story underneath both of them is almost the same. It's a story about distance, about what distance does to the truth. Because the very first reaction to little red dots wasn't quiet curiosity, it was alarm. Some researchers openly wondered if the standard model of cosmology, the framework that's held up astonishingly well for decades across galaxies, across the cosmic microwave background, across gravitational lensing, across nearly every test we've thrown at it, might actually be wrong, broken, in need of a complete rebuild. That's a big claim. And for a while it felt justified, because nothing about these objects fit cleanly into what we expected. But look at what actually happened once astronomers slowed down and looked closer. The impossible black hole masses turned out to be an illusion caused by gas distorting the measurement. The apparent absence of host galaxies turned out to be an illusion caused by extreme distance hiding faint structure. Even the strange, singular nature of these objects, the idea that they were something entirely new in the universe, might turn out to be something more familiar than expected, just witnessed from an angle and a distance we'd never had the tools to study before. Distance distorts what we see, not metaphorically, literally, physically, mathematically. The further away something is, the less information reaches us, and the easier it becomes for the missing information to get filled in with assumption, with alarm, with the story shaped more by our own expectations than by the object itself. I think that's true of more than galaxies. Think about how often we do this with people. Someone shows up in our life and all we get is a fragment, a single interaction, a rumor, a post, a version of them stretched across a distance too wide to carry the whole picture. And in that gap, in the space where the full story should be, we fill it in ourselves. We build a version of them out of assumption, and then we treat that assumption like it's the truth. The little red dots looked impossible because we were only seeing a fraction of what they actually were. Not because they were breaking the rules of the universe, but because we hadn't yet found the right distance, the right angle, the right instrument to see the rest of them clearly. That's worth sitting with. How much of what looks broken or strange or too extreme to make sense is actually just incomplete, not false, not impossible, just unfinished from where we're standing? There's a researcher quoted in coverage of this discovery who put it simply, other classes of apparently exotic objects Webb found in its earliest years might reveal their more ordinary nature too, once we find something closer to compare them against. This isn't the first time the universe has looked broken from far away, and it almost certainly won't be the last. That reframes the whole mystery, doesn't it? It's not really a story about the universe defying its own rules. It's a story about the limits of a first glance, about how something can look monstrous or impossible or unprecedented, right up until you get close enough or patient enough to actually understand it. And there's a specific kind of humility hidden in this, if you're willing to notice it. The scientists studying little red dots didn't stay attached to their most dramatic hypothesis. When the black hole mass estimates turned out to be inflated, they corrected it instead of defending the exciting version. When a completely different explanation showed up, the black hole star model, they didn't dismiss it just because it complicated the story they'd already started telling. They're still holding both possibilities at once, still testing, still willing to be wrong in public. That's rarer than it should be, not just in science. In general, most of us, when we build a theory about something, a person, a situation, ourselves, get attached to it fast. We stop looking for evidence that might complicate it. We defend the story instead of chasing the truth underneath it. The little red dots are still, technically, unsolved, not because nobody's smart enough to solve them, because the honest answer, right now, genuinely is, we don't know yet, and there are at least two very different explanations still standing. I think there's something almost restful about that, if you let it be restful instead of frustrating. Not everything needs to be resolved immediately to be worth understanding. Some mysteries are more honest left open than forced shut with an answer that isn't fully earned yet, so we sit with the not knowing a little longer. And somewhere out there, 600 million years after everything began, something small and red and impossibly bright is still waiting for us to get close. Let's zoom out for a second, because I don't think the emotional weight of this discovery fully lands until you see where it actually leads. If either explanation turns out to be right, the dusty, furiously feeding black holes, or the pulsating black hole stars collapsing in on themselves. Both stories end in the same place. A seed, the very first seed of a supermassive black hole planted at the dawn of everything. And that matters more than it might sound like at first, because every large galaxy we've ever studied, including our own, has one of these monsters sitting at its center. Ours is called Sagittarius A star, quiet now by cosmic standards, barely stirring, but every supermassive black hole we know of, in every galaxy we've ever pointed a telescope at, had to start somewhere. Had to begin as something small enough to fit inside a single pixel of a deep field image, the way these little red dots do now. That means what Webb caught wasn't just a strange, isolated curiosity floating in deep space. It was possibly a snapshot of infancy. The literal beginning of the same kind of object that, billions of years later, would sit at the gravitational heart of galaxies like the Milky Way, shaping how stars form, how gas moves, how entire cosmic structures hold themselves together. Here's the part I find genuinely humbling. Structure, on the largest scales the universe offers, doesn't seem to start with something big and slow and dignified. It starts violent, chaotic, almost embarrassingly small and messy compared to what it becomes. A star tearing itself apart while a black hole is born inside it. Or a black hole feeding so aggressively it breaks its own theoretical speed limit, wrapped in a shroud of gas it hasn't even finished consuming yet. Neither of those sounds like the graceful beginning of a galaxy's future anchor. They sound like accidents, like something going wrong, not right. And yet, give it a few billion years and that violent, chaotic mess becomes the quiet, stabilizing center of an entire galaxy. Something billions of stars orbit around, generation after generation, without most of those stars ever knowing or needing to know how strange and unstable the thing at the center once was. I don't think that's just true of black holes. I think almost everything that eventually becomes stable started out looking like a mess. A relationship that becomes steady and quiet years in usually didn't start that way. A person who becomes grounded and calm in their 30s was rarely grounded and calm at 19. Even you, whoever you are, listening to this right now, whatever feels settled and certain about your life today probably didn't start out that way. It probably started messy, uncertain, maybe even a little violent, emotionally. And it became something steady anyway. The universe doesn't seem to build stability first and chaos second. It seems to build chaos first and let stability be something that's earned, slowly, over an almost unbearable amount of time. That's not a comforting thought in the way motivational content tries to be comforting. It's not everything happens for a reason. It's closer to something more honest. Beginnings are allowed to be messy. They're almost required to be. The mess isn't a sign that something's going wrong. Sometimes it's just what the early stage of something enormous actually looks like before there's been enough time for it to settle. If Sagittarius A star started out anything like a little red dot, chaotic, violent, wrapped in gas, barely holding itself together, then it took roughly 13 billion years to become the quiet, stable anchor it is today. 13 billion years to go from chaos to calm. I don't know what that timeline means for anything in your life. I'm not going to pretend I do. But there's something in that number that feels worth carrying with you anyway. Whatever mess you're standing in the middle of right now, it doesn't get to define the whole story. It's just the part of the story that happens to be visible from where you're standing. Some things need that much time, and they're allowed to take it. If you're still here with me this far into the video, I want to invite you to subscribe to the channel and come back and explore these questions with us every day. We spend a lot of time in places like this, the edges of what we actually know, and it means something that you'd choose to spend this much time here too. While I have you, I'm curious about something. Do you think we'll ever get close enough to actually confirm which of these explanations is true? Or is this one of those mysteries that stays open for another decade, another generation of telescopes, another set of researchers picking up where this one left off? Tell me in the comments. I read every one of them. Okay, back to where we were. Because there's one more layer to this story I haven't given you yet, and it's the part that made me want to make this video in the first place. Whichever explanation eventually wins, there's a bigger instrument still coming that might settle this for good. Astronomers are already planning follow-up observations, hunting for something specific, a closer, lower redshift version of a little red dot. Something similar enough in structure, but near enough to Earth that we could actually study it in detail instead of squinting at a single, distant point of light. There's a nickname for one candidate they've already found. Researchers call it the saguaro. Closer, brighter, more detailed than anything from the deep field. A version of these mysterious objects we can actually get close to. And the hope is simple. If we can study something like it up close, the way you'd study a nearby specimen instead of a blurry photograph, we might finally be able to tell definitively whether we're looking at a black hole in a dust cocoon or a star collapsing into one. That's the next chapter, not a theory. An actual plan, already in motion, to go looking for the answer instead of just guessing at it from a distance. And I think that's the part of this story that deserves the most credit, honestly. Not the discovery itself, the response to it. Faced with something genuinely strange, something that briefly looked like it might upend everything we thought we understood about the early universe. The response wasn't panic, and it wasn't certainty either. It was patience. Go find something closer. Go look again. Go check the math one more time before you announce the universe is broken. There's a kind of quiet courage in that, I think. The willingness to sit inside we don't know yet for as long as it takes to actually find out, instead of rushing toward whichever answer feels most exciting or most comfortable. Somewhere out there, right now, that closer, more detailed target is sitting in someone's observation queue, waiting for its turn in front of a telescope. And when that data finally comes back, one of these two explanations is going to get quieter, and the other is going to get louder. That's how this usually goes. Not a dramatic reveal. A gradual shift as more evidence accumulates on one side of the scale than the other. But for now, both possibilities are still alive. Both are still technically true candidates for what these strange little dots actually are. And there's something almost poetic in that, if you let yourself sit with it instead of rushing past it. Somewhere, roughly 600 million years after the universe began, something happened. Something violent and brief and almost unbearably intense. And whatever it was, a black hole devouring its surroundings, or a star collapsing in on its own impossible mass, it left behind a signature bright enough and strange enough to cross 13 billion years of empty space and land, finally, in the mirrors of a telescope built by people who wouldn't exist for billions more years after that. That signal had nowhere to go for almost the entire history of the universe. And then, one day, it arrived exactly when someone was finally looking. So here's where we land. A dot, small enough to lose inside a single pixel, red enough to stand out against 13 billion years of darkness. And for a while, strange enough to make some of the most careful minds on this planet wonder if everything they understood about the universe needed to be rebuilt from scratch. It didn't need to be rebuilt. It needed to be looked at more closely. Maybe it's a black hole, wrapped in a cocoon it hasn't finished consuming, feeding faster than physics is supposed to allow. Maybe it's a star so massive it couldn't survive its own weight, pulsating in its final moments, shedding its outer layers as something new is born inside it. Maybe, somewhere out there, it's both. Different objects, wearing the same disguise, at the same distance, in the same sliver of cosmic time. We don't know yet, and I'm not going to pretend that not knowing is a flaw in the story. It's the most honest part of it, because somewhere between 600 million and 2 billion years after the universe began, something happened that was violent enough and bright enough to still be visible now, reaching us across a gap of time so vast it barely fits inside a sentence. And whatever it actually was, it eventually became something quieter, something stable, the kind of thing entire galaxies learn to orbit around without ever remembering how chaotic it once was. 13 billion years. Chaos to calm. I keep thinking about how strange it is that we found this at all. That a species barely a few 100,000 years old built an instrument capable of catching a whisper from the beginning of everything. That we noticed a red dot others might have scrolled past, and instead of looking away, we asked what it was. Maybe that's the part worth sitting with tonight. Not the black hole, not the star, the asking. If this stayed with you, share it with 5 people who'd sit with it too. And if you have thoughts, real ones, not the polite kind, leave them in the comments. I mean that. Tell me what confuses you, what you don't buy, what you'd want me to go looking for next. Somewhere out there, something is still becoming what it's going to be. So are you.